welcome to the National Solar Observatory, or NSO. We're really glad you could join us today, and we hope that you find our Eclipse web series helpful in the run-up to the major event next August 21st. Here at NSO, the Sun is our number one priority, and what better excuse to share what we know about our celestial object than the major solar eclipse coming up next year. This is going to be a particularly special event since it's the first time that an eclipse has swept across the US in almost a century. An eclipse of some kind is going to be visible from every state, and for a lucky few, they're going to get the chance to witness a total solar eclipse. So from Oregon down to South Carolina will be the place to be on August 21st, 2017. The difference between the total solar eclipse and a partial eclipse, which will be visible from the rest of the country, is that on the path of totality, the moon will completely block the entire disk of the sun. For the rest of the country, those who will experience a partial eclipse, the moon will move in front of the sun, but won't completely block it. So this webinar series is geared towards helping people prepare for the solar eclipse coming up. We're going to provide information that will hopefully be helpful on Eclipse Day, but also in the run-up to the eclipse, and give you ideas on ways to engage and educate your local community. If you have anything that you'd like us to cover, or if you have questions, feel free to email outreach@nso.edu, or you can get us on Twitter at @NatSolarObs, and we'll get back to you with answers and ideas as soon as we can. So each month in our webcast, we're going to cover three main topics. We're going to have our Solar Spotlight segment, where I'll introduce some basic solar concepts that will hopefully help you understand what's going on during the eclipse a little better. We'll have an Eclipse Tips segment, where we'll demonstrate some fun activities that will help to get kids engaged and interested in what's going on during the solar eclipse. And finally, we'll have a special guest scientist that will join us each week. They're going to share with us some of their cutting-edge research that's related to the sun or the solar eclipse. All of this will be archived on the NSO webpage, www.nso.edu, or you'll be able to get it on the NSO YouTube channel as well. So, let's get started. We're going to begin our web series today by introducing the sun by the numbers. We're also going to give you some context onto why it's important for us to understand the sun and how it can help contribute to our knowledge of other celestial objects and the universe overall. We're going to have a special guest speaker this afternoon, Dr. Adam Kowalski, who is an assistant professor here at the National Solar Observatory, and he's going to talk about other stars and how the sun can help us understand what's going on elsewhere in the universe. So let's talk numbers. The sun is the biggest object in our entire solar system, and trying to understand or comprehend just how big it is really quite difficult. It's more than 800,000 miles across, which is an enormous number. It's one that's really difficult to comprehend. One way to think about it is that the sun is 109 times bigger than the Earth in diameter. So that's not in volume, that's just if you lined the Earth up side by side 109 times. Then you would finally get to the diameter of the sun. If you were to fill the sun full of Earths, you would need more than 1 million Earth-size planets to fill the volume of the sun. So hopefully that will help to put things in perspective. We're talking big scales here. By comparison, the Earth is 4 times bigger than the moon. So that means that we need 4 moons lined up side by side to compare to the size of the Earth. When we look at the sky, the moon and the sun look roughly about the same size, but we know that the sun is significantly bigger than the moon. In order for that to be the case, that means that the sun has to be significantly further away than the moon is. In fact, that's a factor of 400. So the moon is 400 times smaller than the sun, but the sun is 400 times further away than the moon. And that means that when we see the two of them in the sky, they look about the same size. Lucky for us, it's that fact that means that we get solar eclipses in the first place. Because the two bodies are almost exactly the same size from our perspective, when they are aligned, they completely eclipse each other. The location of the Earth in the solar system is fortuitous in many different ways, not least of which is the fact that we live in a special area called the Goldilocks zone. The Goldilocks zone is a region of habitability around a star, and this is not just our sun, this is any stars that may have planets around it. And this is where the conditions are just right to be able to support life. So it's not too hot, it's not too cold, it has enough atmosphere to support the air that we need to be able to breathe, it has the right atmospheric pressure to be able to have water, and lucky for us, the Earth is right in the middle of the Goldilocks zone. As you can see here, Venus is inside of the Goldilocks zone, and so being able to support life would be very, very difficult, if not impossible. And on the other side of us, Mars is on the outer edge of the Goldilocks zone. It's likely to be on the boundary of being able to support life. So the sun is the reason that we are able to survive on this planet. It allows the crops to grow so we have food to eat. The light that comes from the sun enters our eyes and allows us to see. We're completely dependent on the sun, and yet we take it for granted a lot of the time. Hopefully through this Eclipse series, you'll start to realise just how important the sun is and how much value it brings to our everyday life. As always, if you would like to hear more from us, please feel free to get in touch. You can find us on Twitter at @NatSolarObs. You can get us on Facebook at National Solar Observatory. And we now have an Instagram account at National Solar Observatory on Instagram.